So this is lecture number 5, unit 5. Okay, we are discussing the third problem on nodal analysis. So you can see the remaining lectures link in the description. So question is, find the value of Vx in the circuit of figure below. Find the value of Vx in the circuit of figure below. So you can see the circuit here, it looks complex, but it will be very simple. Okay, in order to solve this, we'll be getting only one equation. We have to solve one equation to find the answer. So here we need to find Vx. Okay, first of all I'll be drawing the graph. Okay, so how to draw the graph? I need to identify the number of nodes. Node 1, node 2, node 3 and node 4. We have totally 4 nodes, so I'll draw all the 4 nodes here. So each and every element will be replaced with the line segment. So this 30 volt source replaces the line segment, and 6 Vx will be replaced with the line segment, and the 5 ohms will be replaced with the line segment, 4 ohm will be replaced with the line segment, 3 ampere source will be replaced with the line segment, 1 ampere source will be replaced with the line segment, and 2 ampere source will be replaced with the line segment. It is my graph. So I need to draw the tree. So while drawing the tree, I need to draw the line segment. Okay, and I need to make sure all the voltage sources available in the circuit are in tree, and all the current sources available in the circuit are in co-tree. So I need to make sure that is a rule for drawing the tree. So for drawing tree, so I need to consider all the 4 nodes. All the 4 nodes are considered. So we have voltage source here, so I am connecting it, and we have a voltage source here, control voltage source, I am connecting this, and we have current sources. Okay, so all the current sources should be in the co-tree, so I will not draw in the tree. So I can either use 5 ohm or 4 ohm. So I am going to take this 4 ohm to complete the tree. So total number of nodes here is 4, and number of twigs. Okay, twigs are the branches of a tree is n minus 1, which is 3. So I have 3 twigs. Okay, here the branches which is not available in the tree and which is available in the graph, I am going to call it as co-tree. So co-tree I am going to mention using dotted lines. So all the co-trees, and make sure all the current sources are in the co-tree. Okay, 1 ampere source in the co-tree, 2 ampere source in the co-tree. So all the current sources are in the co-tree. So we completed this. So for my understanding, I am going to mention the voltages. So it is my 30 volt. So it is my, so I am writing the polarity properly, 6 Vx, and we have plus or minus Vx. So these are the polarities I need to make sure, and I can even mention the currents, 1 ampere, 2 ampere, 3 ampere. So these are all things will be useful while applying the KCL. Okay. So there are 2 voltage sources. Okay, 1 voltage source and 1 control voltage source. Okay. So totally we have 3 branches in the tree. So 2 upper nodes, 1 and 2, can form a super node because we have a voltage source between this, and we have voltage source between this also. Okay, all can be joined together. Okay, 1, 2 and 3 can be joined together and form a super node because we have voltage source connected. So we are going to combine all the 3 and form a single super node. So I will be applying KCL only to this node. Okay, I will be applying KCL only to the node 4. I will be applying KCL only to the node 4. We will get only one unknown, so we can get the answer directly. Check here, applying KCL to node 4. So what are the branches connected to the node 4? If you see, so we have this branch connected, 1, 2, 3, 4. There are totally 4 branches, 1, 2, 3, 4. 4 branches connected to the node 4. So I need to know the current which is flowing through that branches which is connecting to the node 4. So this current we already know, which is 1 amperes. and we need to find out the current here. We need to find, we already know the current here, 3 amperes, and we need to find out the current here. Okay, I can say 1 ampere current is entering the node 4. 1 ampere current is entering the, because the arrow mark is towards the node 4. So I can say 1 ampere current is entering the node 4. That is the first point. 3 ampere current leaving the node 4. So we have 3 ampere, the arrow mark is away from the node 4. So 3 ampere current is leaving the node 4. And then the current through this 4 ohm is, so we know that V equal to IR, right? So here Vx is given. We need to find out what is I. So I can write it as Ix. Okay, Ix times R is 4. So Ix is equal to Vx by 4. Ix is equal to Vx by 4. So Vx is by 4 is a current which is entering the node 4. Okay, so why it is entering? Because I need to assume the direction based on the polarity assumed. Okay, here the polarity assumed is positive on the top and negative at the bottom. If it has to obey the passive sign convention, current has to enter positive and leave negative. Current has to enter positive and leave negative. If it is entering positive and leaving negative, it will enter into the node 4. So Vx by 4 is a current which is flowing through 4 ohms, which is entering the node 4. It is entering the node 4. So next I need to know the current flowing through this 5 ohms. I need to find out the current flowing through this 5 ohms. So right now I don't know the direction of it. So I am going to consider this. Okay, I am going to consider this tree, and I am going to consider only one link. Okay, so the link which I drawn for this 5 ohms, that need to be considered. So I have drawn like this, and link which I drawn for the 5 ohms. We know the voltage here, which is Vx. We know the voltage here, which is 30 volt. We know the voltage here, which is 6 Vx. So we need to find out the voltage here, that I can decide based on the current direction. So current direction is clockwise, so I am going to write plus minus. I'll write it as V5. I need to find out what is the voltage across the resistor. From that I can find out the current through the resistor. Okay, because I know voltages of all the other branches. Okay, I know voltages of all the other branches. If I apply KVL to this, I can find out this voltage. So if I apply KVL here, so I can start with plus V5. Okay, we have stated here plus V5, and then current is entering negative and leaving positive, so minus Vx. Okay, we can see minus Vx here. The current is entering positive, leaving negative, so plus 30, and current is entering positive, leaving negative, so plus 6 Vx. Okay, equal to 0. So I need to find out what is V5. So V5 is equal to, so I can take everything to the right hand side. So minus Vx become plus Vx. So plus 30 become minus 30, plus 6 Vx become minus 6 Vx. So plus Vx minus 6 Vx, it will become minus, sorry, so give me a minute. So I mistakenly closed this. Okay, so I'll redraw this. So we have this, so plus minus Vx plus minus 30 plus minus 6 Vx, and we have a link. I am forming a loop using this link, and this is the current direction. So based on the current direction I am specifying the V5. So if I apply KVL, I will get plus V5 minus Vx plus 30 plus 6 Vx is equal to 0. V5 will be equal to plus Vx minus 30 minus 6 Vx, and then so we can write V5 is equal to minus 5 Vx minus 30. Minus 5Vx minus 30, that is what your V5. So I can take minus outside, so it will become minus of 5Vx plus 30. minus of 5Vx plus 30. Now current flowing through this. Okay, so I can decide the direction of the current like this, because it has to enter positive and leave negative. So if it is in this direction, the current will be entering the node 4. So current will be entering the node 4. What is the current entering the node 4? So voltage by resistance, V5 by R. So V5 is minus of 5Vx plus 30 by 5. Okay, R is 5. So minus of 5Vx plus 30 by 5. So that is the current flowing through the 5 ohm resistance. Okay, so now you know all the currents. 1 ampere is entering, 3 ampere leaving, Vx by 4 entering, and then minus 5Vx plus 30 by 5 is entering. So now we need to apply the KVL. So here in this direction we have minus of x plus 30 by 5. So in this direction, so we have Vx by 4. So I can apply KCL at this node 4. If I apply KCL at this node, 1 ampere is entering, so plus 1. So plus 1. And 3 ampere is leaving, so minus 3. So Vx by 4 is entering, so plus Vx by 4. And then minus of 5Vx plus 30 by 5 is entering, so minus of 5Vx plus 30 by 5 is entering, which is equal to 0. So that is what the first equation. Just solve this equation. So 1 minus 3 will be minus 2 plus Vx by 4 minus 5 Vx by 5. I am just separating this. Minus 30 by 5 equal to 0. So 30 by 5 is 6 times, so minus 6. So minus 2 plus Vx by 4 minus Vx minus 6 equal to 0. So I need to take LCM for this 2, and I can add this 2 because minus 2 minus 6. So it is minus 8. I can take it to the right hand side, it will become plus 8. So Vx minus 4 Vx by 4. If I take LCM, I will get 4. So Vx minus 4 Vx by 4 equal to 8. So minus 3 Vx equal to 32. Vx will be 32 by minus 3. Okay, Vx will be equal to minus 32 by 3 volt. Okay, thank you.